All right. Now we are ready to introduce feed-forward neural networks, or they're also called fully connected neural networks. And so at first, we're going to see our logistic regression as a neural network, right? So we are going to schematically represent it like this. So we are going to have the input layer. This is my input layer. So it consists of two variables, right? So, and basically, we input the values of these variables into our input layer, right? So, and then it has an output layer which computes the output. And what happens in this output layer is a combination of two operations. So the first operation is a linear function. So we are applying a linear function to our input, and then we are applying a nonlinear function to the result of that linear function. And so we have our input vector. So the whatever sits in the output layer is called a neuron. Well, and associated with this neuron are a vector of parameters. And these are the values of the parameter. Right? So then what it does, the neuron, so once it receives the input, it calculates the dot product of the input with parameters. Or you can also think of it as a matrix product, right? So of beta and X transpose. And then it applies the activation function, right? So we associate the vector of parameters and the activation function with this neuron, right? So it whatever comes out of this dot product, it applies this activation function to the result. All right. Now, before you're going to do the quiz, let me explain a little bit about what is going to be in this quiz. So this quiz is about representing Boolean functions as artificial neural networks, right? So, and then let's just think of a Boolean functions and an or, right? So and. So and. A Boolean function is a function of true and false, right? So we're going to represent true as 1 and false as 0, right? So then you can kind of schematically plot the graph of the function end of the two axes, so x1 and x2, right? So we're going to have two variables, x1 and x2, and then we are going to, so both can be either 0 and 1. And then we are going to plot the x1 and x2, the result of the Boolean operation, as either 0 or cross. So cross represents 1, right? So if x1 and x2 are both zeros, then we will get 0, right? So if x1 is 0 and x2 is 1, we still get 0, right? So because false and true is false. Same for when x1 is 1 or true and x2 is 0, right? And only when both x1 and x2 are true, then we're going to get true. So true and true is true, or 1 and 1 is 1, right? So and here we get 1. So let me just draw a cross here. So cross represents 1. Now, if you want to somehow approximate this with a logistic regression, you can, right? So because you can separate these two classes, so zeros and ones by a straight line, right? So and whatever is below the straight line, you classify as 0. Whatever is above the straight line, you classify as 1, right? So these two classes are linearly separable. Okay, now let us think about the same the OR function, right? So OR, Boolean OR. So x1 and x2. Now, if both x1 and x2 are zeros, so which means false, then false or false is still false, right? So I'm going to put 0 here. But if either x1 or x2, if at least one of them is true, then we're going to get true. So cross means true. So true here, and true here. And still, so we have two classes, so zeros and ones, and they're linearly separable. Okay, but how about this function that is usually called XOR? So this is mutually exclusive OR, right? So XOR is when x1 let me just do the truth table. So if x1, so x1 can be true and x2 can be true, and then XOR is going to be XOR. XOR is going to be, well, let me do different. So x1, x2, and XOR of x1 and x2, right? So x1, x2 can be both true, can be true, false, false, true, and false, false. Now this XOR is true even only if precisely one of the two arguments is true and one is false, right? So for true, true is going to be false, and for false, false is going to be false, but for true, false is going to be true. Right, so can we represent this XOR Boolean function as a logistic regression? And well, if you plot the graph in a similar manner, right? So you will see that if this is x1, this is x2, and the graph looks like this. If they're equal, we're going to get false. If they're different, we're going to get true. And now, with just 4 points, these two classes cannot be separated by a straight line, right? So no matter how you try to separate them, you cannot separate them by a straight line. So which means that this XOR function cannot be approximated by a logistic regression. Well, the point of this quiz 4 is to come up with some way to approximate this XOR function with several logistic regressions put together, so stacked on top of each other. And this will give us a motivation to introduce artificial neural networks. And this is what we are going to see, that for artificial neural networks, so they're basically some kind of a very complex and very, but still they boil down in stacking several sigmoid or maybe some other types of so-called layers on top of each other and calculating according to these layers. Well, in any case, please try to do this quiz 4, and then we are going to introduce an artificial neural network.